Okay, we are going to be looking at some square root functions in this lesson. So first of all, I'm giving you this equation. It certainly does not look like it has a square root in it, but I kind of want to show you where this gets generated from. So first of all, if you look at this equation, you should be able to recognize that it's a special kind of equation. It's called a quadratic because it's got an exponent of 2 in it. And remember that quadratics make parabolas. And this happens to be a sideways parabola, remember, that because it says x equals instead of y equals. So this is a sideways parabola, just so you know. And maybe you don't know that, but if you don't, we will get to it, okay? This is a sideways parabola, and it has a vertex of 2 and 1. Okay, that's the vertex. It has a sideways parabola. If you did not know that, that's okay. I just want to show you this. This is the graph for that function, just so that you can kind of see what that looks like. And then I just want to show you really quick, if you solve this equation for y, okay, we're going to solve this equation for y. What I will do is I will subtract the 2 over, and so then I have x minus 2 equals y minus 1 squared. In order to solve it for y, I would need to take the square root of both sides. And when I'm taking the square root of both sides and I'm taking the square root of something that's already squared, those two will undo each other. And over here, I need to have a plus or minus. So I will have y minus 1 equals plus or minus the square root of x minus 2. And then, of course, to solve for y, I will just add that 1 over. So it will look something like that. Is another way to manipulate this equation. Now, here's what I want you to notice. The point 2, 1 shows up in both equations. Here in a parabola that's in vertex form, and here, notice this is the point 2, 1. It happens to be the vertex here. Because there's this plus and minus out in front, the plus gives you the top half, and the minus gives you the bottom half of this parabola. Okay, notice how you can go from something that does not have a square root function in it to something that does. Just kind of a point of interest in how those get generated, and now we're going to kind of look at these. Here are a whole bunch of square root functions and their graphs, so you can see this. I want you to notice that these are just halves of parabolas. That's all they are. For instance, this one would be down here. The other half of it would be here. Notice that you only have a positive root out here, so you only have the top half of the parabola. Over here, I want you to notice that it's negative, so you have the bottom half of a parabola. I also want you to notice that right here and here give you sort of the starting point of that square root function. Notice when it gets pulled out of the square root, you have to change the sign on it. So when it gets pulled out of the square root, the center or the starting point of this actually becomes -4 and -2. And you can see that on your graph right here. This point right here is -4, -2. Okay? Notice this would have like a +0 back here, so my center would be, or my starting point would be 0, 1, which makes sense right here. Okay? So, and if you look over here, this and this kind of give you your starting point. The one that's underneath the radical, the sign has to get switched on, so your starting point is 2, 3. Okay? It has a negative radical out in front, or a negative out in front of the radical, so you're going to get the bottom half of that parabola. If it's a positive out in front, you'll get the top half of the parabola. All right, so here's a bunch of square root functions, and we are going to look at them and determine their domain and range. This is the basic square root of x function right here. It looks something like this. Notice it's the top half of a parabola because I only have the positive roots here, okay? And so when I have the positive root, I first of all want to look at your domain. And remember, your domain is what your x values can be. And so to find your domain, I am going to take a vertical line, and I'm just going to think about moving it along this line and seeing where the pink line starts to intersect the blue line. Okay, I'm moving along my x-axis. So obviously it's not hitting the blue line yet, it's not hitting it yet, it's not hitting it yet, but it does start to hit the blue line here at 0, and it will continue to hit the blue line forever and ever and ever and ever, because remember, this square root function is going to keep going up and to the right. Okay, so I start hitting the blue line from 0 up to positive infinity. Now, I can start hitting that blue line at exactly 0. So when I'm doing this in interval notation, I need a bracket here because it can be exactly 0. And then it's going to go all the way up to positive infinity. With infinity, you'll never reach a destination because there's always one number bigger, so you have just a parentheses there. Okay, so that's how it looks in interval notation. In set notation, your domain will look like this. The set of all x, such that, and then you describe for me. The blue lines, these blue lines all have x values that are greater than or equal to 0. It is greater than or equal to 0. Okay, and now we're going to look at our range. And our range is what your y values can be. So you're going to take a dotted line, you're going to start at the bottom, and you're going to think, okay, when do I start to see y values? So here's the line I'm going to use, this green one right here. I'm starting at the bottom and I'm going to move up. So I'm not hitting the blue line, not hitting the blue line, not hitting the blue line, not hitting the blue line. Right here is where I'd start to hit the blue line when my y values are 0. And then of course when my y values, get bigger and bigger and bigger and bigger and bigger. I'm moving the wrong line, sorry. Remember that the blue line is going to get wider and fatter as you go, and so that will help you. Just think that you're going to start hitting your y values when they are 0, so this will look the same. And of course, in interval notation or set notation, it'll look like this. Okay. I'm going to lock this one right away so that that doesn't happen again. All right, here we go. Interval notation here. Now we've got a little bit different graph, but that's okay. So I want to find my domain again. In my domain, I'm going to start here. This is your starting point right here at 0, 1. So when you're looking at your x values, I'm going to start to the left and move to the right. So my pink line is not hitting the blue, it's 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 not hitting the blue. Oop, it starts to hit the blue line here. And then it will continue to hit the blue line as long as I move it to the right. So it will always hit the blue line from exactly 0 to positive infinity. Or, of course, when your x values are greater than or equal to 0. Okay? Then, if you look at the range again, you're going to start at the bottom down here, and I'm going to move this up. So I'm not hitting the blue line, not hitting the blue line, not hitting the blue line. Oop, I start to hit it right here when my y values are 1, or, of course, as I continue to move up. And remember, this line is going to go up and up and up and up like that, so they will eventually intersect. Okay? So your ranges, in this case, will go from exactly 1 up to positive infinity, and your in set notation it will look something like this. All right, a couple more of these here. Very similarly, okay, here's your starting point. I'm going to lock this too, actually, so that this, I should have done this before, I'm sorry. Okay, your starting point is right here at -4, -2. And so your domains, as you're going across, your domain, I'm not hitting the blue line, not hitting the blue line, starts to hit the blue line right here at -4 and will continue to hit the blue line to the right of that. And so your x values here go from -4 up to positive infinity. And of course, in set notation, it'll look like this. Okay. And then your ranges, that would go this way. Here, if you want to think about this, this would continue to go on down and to the right forever and ever. So the blue and the green line actually would intersect starting anywhere down here, okay? They'd eventually intersect way off to the right. So I'm intersecting the blue line, intersecting, always hitting the blue line, hitting the blue line, hitting the blue line, till I get to here. It continues to hit right here at -2, and then anything above my blue and my green will never intersect, even though both lines go on forever and ever, okay? So your range actually goes from negative infinity up until I hit the point -2, okay? Or in set notation, it'll go like this, y such that y is less than or equal to -2, because it's all the points that are smaller than or equal to -2. All right, I think I am going to skip this one and have you try it in class. I think you can handle this. If you want to hit pause and try this on your own, I will write the answers up here, but I am not going to take the time to explain this here. But here's what it would look like. Okay. All right, and then we've got one last one, which item is not really any different, but I'll explain one more time, kind of how this works. And it goes like this. Again, your starting point is right here at 0, 0. Okay. Your domain will be all, as you move to the right, all of these x values are greater than or equal to 0. So your domain will go from 0 up to positive infinity in interval notation. In set notation, it'll go x such that x is greater than or equal to 0. Okay, and then your range, you are hitting, if I go down here, I'm hitting y values all the way from negative infinity up until I hit this point right here at 0, and it can be exactly 0. And then, of course, it would look like this. Y values, all of these down here have y values because they're getting smaller as they move to the right that are less than or equal to 0. All right.